Well, welcome everyone. Late in the day here. Thank you for coming. This is the Introducing AWS App Mesh session. I'm Nick Colt. I'm a Principal Product Manager at AWS. So we're going to start today talking about some big picture questions. Why a service mesh? What is a service mesh? Why would you be interested in or need a service mesh? How does AWS think about service mesh and app mesh? And then after we cover those kind of big picture ideas, then we'll zoom in and talk about app mesh in particular, how it works. And I'll even do a live demo. Hope you have a phone or laptop with you. You can participate in the demo. So big picture, app mesh. I want to set the stage for how we're thinking about app mesh, not just today, but moving forward. So the way we think about app mesh at AWS is what we call application level networking. So the idea is that if you look historically at containers or microservices, or even regular services that are running on EC2, when you start building applications based on containers and microservices, one of the first things that you have to do is build a bunch of network infrastructure. You have to create a virtual private cloud or VPC. You have to create subnets, security groups, NAT gateways, internet gateways, route tables, a whole bunch of stuff that you have to do before you even get to your application. On the other hand, if you're developing microservices and you're running a microservice-based architecture, your developers really just care about the applications and which application can talk to which other application, which service can talk to which service, and the logging and the observability around those services. And they don't really want to have to think about all of that networking stuff. The networking stuff is implementation details that an application shouldn't really have to know about. And so app mesh is the first step towards achieving a vision of an application level network where operators and developers can focus on their applications and think about what their applications need, and they don't have to think about the network. So app mesh is a step in that direction. App mesh, because it's application level network, it works across many different compute primitives, including EC2, ECS, Fargate, EKS. Eventually, we'll incorporate things like API Gateway and Lambda. So that's how you should think about app mesh, is that it's application level networking that works across compute primitives. And to just hammer that point home, I want to emphasize if there's one thing to take away from the presentation today, if there's one thing that you remember, if there's one picture you take of a slide, it's this one, which is that app mesh works across compute services. It is not tied into a specific container orchestrator or compute primitive. So it works with Amazon ECS, which is our Amazon AWS native container orchestrator. It works with Fargate, which is our serverless container platform. It works with EKS, which is our managed Kubernetes platform. It works even with services that are running directly on EC2 that aren't even running in containers. And we'll see that in the demo that I do. Also works on Kubernetes. If you're running your own Kubernetes cluster, you're not using the managed Kubernetes service. Works with that also. Works equally well with all of these compute services. So just keep that in mind. This is not specifically tied to containers. It's not specifically tied to ECS or Kubernetes. It's application level networking across compute services. So now I want to take a step even farther back and look at the need for a service mesh in general. And as you may have heard, Amazon is a customer-obsessed company. That's one of our leadership principles. And so one of the things that customer obsession means is that we listen really closely to our customers and the problems they're having and the things that make them happy. And there's really nobody better to explain that than a customer, which is why I'd like to invite Nitin Mahajan to the stage, who is the executive director of service engineering at Edmunds.com, and he's going to talk about the journey that they're going through at Edmunds and the benefit of Service Mesh.
Thanks, Nick. Good evening, everyone. And as Nick mentioned, I'm Nitin Mahajan. I work for Edmunds.com. In my current role, I provide data as a service. I'm responsible for providing data as a service at Edmunds. And what it means is acquiring data, converting raw data into rich domain objects, and exposing that data via microservices APIs. So we at Edmunds, on the business side, help car manufacturers market their new car models. And we help over 20 million monthly car shoppers who visit Edmunds.com connect with over 10,000 dealer partners to facilitate their car buying needs. Now, let me tell you one thing. We at Edmunds loves car so much so that to celebrate our 50th anniversary, we did mount a 1966 Corvette Stingray on a rotating turntable in our atrium. And not just that. To represent our ongoing reinvention, we also mounted the most modern version of Corvette upside down, rotating in the ceiling on top of the reception desk. This transformation took over 50 years. And today I'm going to talk about similar transformation, which is from monolith to microservices. And I'm going to talk about what are microservices, why do you need them, what are the principles you should be following if you're trying to transition from a monolith to a microservice, irrespective of whether you're starting or you're in the middle or you're done with your journey. And lastly, some of the challenges which you face with microservices and where Service Mesh comes into play. So let's start with what are microservices. Microservice is something which is small and focused to do one thing well. And you could say you can rewrite this microservice within a very short period of time. Some people say 2 weeks, but you can gauge based on, you don't really need to spend years on doing this. And lastly, it follows single responsibility principle. So microservices emerge from this world of automation, lean development, fail fast, continuous delivery, domain-driven design. And I would say, I think something which put microservices on steroids is virtualization and cloud. So that's how we talk about microservices on a daily basis now. You hear it everywhere. So at Edmunds, we had made significant progress in our microservice journey. And every journey comes with some challenges. And I'm going to share a story of one of our challenges. A couple of years ago, we made a decision to replace our search engine from Apache Solr to Elasticsearch. And it was a natural progression. Our data was growing, and we wanted new capabilities. And Elk Stack was really amazing at that point in time. And I think it's still doing great. So we took a very standard format for this migration. We said, hey, we're going to build a parallel Elk Stack, a parallel Elasticsearch database, and build services on top of that, and slowly start transitioning our clients to this new service, Elastic-backed service. Now, irony is, 2 years into it, we are still maintaining both systems. So, which basically does two problems. One is we have to pay in terms of maintenance and infrastructure. And even the bigger one is data consistency issues. We have to deal with these two sources of truth. And when your site is powered by two sources of truth, you have to make sure data is consistent, and it's really tough when you're dealing with such things. When we do retrospective, we did not really follow microservice principles when we did this first Solr-backed service, and there were 10, 20, 30 applications which were all connecting to the Solr database. And now, once you have to replace it, you have to rewrite all those 30 applications. Compared to single responsibility principle, you have one application doing one thing. So that's what I think one of the takeaways, when if you're doing microservices, make sure you're not, you segment these things. So taking a step back, I think all of you are familiar with this, but what is a monolith? Monolith is where you have your entire application, all components of application packaged as one unit, whether it's HTML, JS, or all the services. And most of the time, they talk to a single database. And your entire dev team is working on that same piece of software. Now, monoliths are not inherently bad. I think if you're starting something new, or if you have a small team, and complexity of your software is low, it is OK, and it's fine to do monoliths. And they do have advantage, like it's easy to troubleshoot, and if there's a failure, you can find that easily. Where monoliths are bad is when your software complexity grows, and at the same time, your team size grows. That's when you start facing issues with monolith. And the two main issues are how fast you're shipping your software, and number two is scalability. Like if you have to scale, you have no option. You have to scale entire monolith. In this diagram, let's say if service A is which needs more traffic or more compute power, you have no option. You're going to really multiply the entire monolith. So this is where microservices come into play. And the question is, hey, why do you need microservice? In today's competitive world, you cannot go to business and say, I'm going to take 4 weeks, 6 weeks, or 6 months to deploy an artifact or deploy a business feature. What business needs is they want to test their hypothesis multiple times a day or multiple times a week, gather feedback, and make a pivot. So they want to test, they want to collect data, and deploy a next version of artifact, run multiple A/B tests every day. And this is where this modern software development, this microservices architecture is coming handy. And what microservices enables is, it enables you to build small cross-functional development teams, which further enables you to have CI/CD, continuous delivery. That's the whole gist of it. If you think you're doing microservices and you're not able to deploy or ship your software multiple times a day or multiple times a week, I think it's time to recheck. There is something wrong. So I talked about covering few principles. If you are beginning to split your monolith, if you think your team size has grown and complexity is growing and you want to split, first thing I think you need to think of is your microservices should be loosely coupled, and they should have high cohesion. Loosely coupled, don't do what I gave you an example of Solr. If you have so many dependencies, it's not loosely coupled, and you want to make sure you are able to change a software without really impacting anything else. At the same time, you need high cohesion. You do not want to break it so small that to deploy one feature, you have to deploy, or to launch one feature, you're deploying 20 different artifacts. That's where you need to have a high cohesion. And how do you achieve that? This is bounded context. This is a basic design, or I should say very basic domain-driven design pattern. This tells you, how you want to split your monolith into microservices and how to really achieve cohesion while keeping this loosely coupled interfaces. I would suggest, I think reading this is a difficult pattern to implement, but I think it gives you an idea, what you should be doing. How should you be really splitting a monolith? And another view of, I should say, and I think I can talk to Edmund's examples here. You can split your monolith by two aspects. One, by business capability, and second, subdomain. So what I mean by splitting a monolith by subdomain is, if I take Edmund's example, we have subdomain level core services. I don't know if you have visited Edmunds or not, but we need to really show make, model, years of a car. We need to show photos of a car. We need to show what incentives are available in a given zip code. All those services are core services, and that's how a subdomain level service is a vehicle service, or it's a photo service. And the other aspect is business capability. If you are trying to do a car research, or as a business, we want to build a car research capability, that itself is a microservice, or car buying is a microservice. So these are various ways or techniques we have internally used for our microservice journey. And this diagram is showing our current very high-level microservice architecture. And a lot of the principles I talked earlier are applied in this. If I start from extreme right, that is where I think a lot of my responsibility comes into providing data as a service. And extreme right, you see this database layer. We are using heterogeneous database layer. We are using MongoDBs, Elasticsearch, DynamoDB, Redis. And developers have their ability, or they have freedom. That's what's power of microservices. They have ability to pick a database technology based on the use case. And most of our core domain services are written in Java. And this layer is where I was referring to, vehicle API, or a photo API, or a incentive API. In the middle, where do you see the product teams? Are split by business functionality. And product teams can come and do their own development and pick their technology, like Node.js or Java. And they're building like car research service, or they're building a car buying service. This pattern is also called BFF, which is backend for front end. I think Netflix heavily uses this pattern. If I keep going, I think platform team, again, it's a microservice where we build our own gateway. I'm not talking Amazon gateway. This gateway is responsible for caching, resilience. We have Netflix Hystrix library there. And on the extreme end is where, again, product teams come into play. And we use React and Redux for building rich UI components. Now, this is very high-level view of how a microservice architecture will look like. But reality is way more complex than what you see in this diagram. Reality is this. So this is a screenshot from our production environment, which is powering our website. And each of these dots, big dots, are a compute node, whether it's a ECS container or it is EC2 instance. And it is really, really difficult when you're dealing with, we are looking at roughly around 1,000 compute nodes. And it becomes a nightmare when you have to really manage or support a system like this. So with this, I think the challenges we face with microservices, and it's not just us at Edmunds. This is a normal problem, which once you have all these small pieces talking to each other, how do you really control service-to-service communication? How do you really get visibility into service-to-service communication? How do you really organize your small DevOps teams, which are trying to bring innovation in your company? And how do you trust on the security and compliance? So what is missing is, or what is needed is this consistent communication management, complete visibility into this microservices mesh, and failure isolation, protection, and fine-grained deployment controls. And that is where industry has come up with the solution, Service Mesh. And I think with this, I'll hand over to Nick to walk you guys through his awesome demo with AppMesh, plus a lot of other stuff. Thank you.
Thank you. So I think that, especially that chart showing the reality of just how many services are running in production and what's the topology of them talking to each other, shows how there can be challenges with microservices. So with that, then we're going to dive into AppMesh and how it can help you solve those challenges. So in particular, the problem that we're addressing today with AppMesh is what I call inter-service traffic, also known as east-west traffic. So if you think about the case of Edmunds, they've got tons of services running. They own all those services. There may be different teams managing them, but they own all those services, and those services are talking to each other, and that's how their service, their Edmunds.com application works. So that's east-west traffic. That's services that you own talking to each other, as opposed to north-south traffic, which is clients out on the internet coming in your front door and talking to your services. AWS has other products like Application Load Balancer, API Gateway that are designed for that use case. Today, AppMesh is focused on the east-west inter-service traffic problem. So if you think about an environment in which you have many different services running, talking to each other, some of the common things that you'd like to get are things like logs and metrics and traces. What does that mean exactly? Well, if just take a really simple example of two services, if I have service A and service B, and service A is talking to service B, and when I say talking to, I mean it is, for example, making HTTP requests to service B, layer 7 traffic. If I want to log those requests that are going into B, of course, I could just turn on logging in B, depending on how it's implemented, and have logs every time a request comes into B. But now extend that problem to the case of 100 services written in Python and Go and .NET and C++ and who knows what else. And I want to have uniform logs coming out of all of those services. How do I do that? Well, I can go talk to all those different service teams and do a bunch of work to get them all to use the same logging SDK, and hopefully they keep that SDK up to date. Challenging, right? Very challenging to actually get uniform logs out of many, many different services. Same thing with metrics. So what is metrics? Metrics means that I'm like counting something, like I'm counting bytes sent and received. I'm counting the number of requests that succeeded or failed. I want to get uniform metrics out of all of my services. Tracing, I'll talk more about tracing later, but tracing in some ways is a specialized form of logging, where I want to follow a request as it goes through my whole system. Load balancing. So usually it's the case, even in a simple example like just two services, service A making requests to service B, that B actually has multiple endpoints, like it's running as a Kubernetes service, or it's running as an ECS or a Fargate service. There may be 10, 20, or 100 containers that are all serving up the functionality of B. And I want A to load balance to all those containers. But I don't want to have to build in load balancing into the actual application code for A, because then I'd have to go back to the route of saying, oh, I got to download an SDK or write my own, and now I have to have all my teams keep that up to date. I would like the mesh to do the load balancing for me. B might roll out, the service team for B might roll out a new version. They've got a new version of their service. They want all of the clients to start using the new version, but only a small percentage of the traffic, so that they can test and see whether it works in production. They don't want anybody else to know that that's happening. So how can I get A to start sending some of its requests to the new version of B? But I don't want the A team who's developing A to have to know that that's happening or go in and change their code to make that happen. I'd like it to just happen. All of this stuff is kind of getting at the idea of decoupling the service teams. One of the purported benefits of microservices is increasing the velocity of development and delivery. But you can't do that if all your teams are highly coupled to each other, that every time one team does a release, the other teams have to know about it and sign off on it. they need to be able to iterate independently, and that's where you get that accelerated pace of development. So ideally, a mesh would enable them to do that, would help decouple them further, would minimize impact on the application code so that the developers who are super good at writing application code can focus on their unique business logic of their service and not have to spend time on heavy lifting of things like load balancing and traffic shifting. So these are the problems that we're solving with AppMesh. This is where we're focused with AppMesh, is solving these challenges. And how we do that is with a sort of two-part architecture. So there's a proxy component to AppMesh, also called the data plane. The proxy is the thing that physically does all of that functionality that I just described. It is the thing that actually does the load balancing, it does the traffic shifting, it generates the logs and the metrics, does all that stuff. Of course, if the proxy is going to do all that, somebody has to tell it what to do. You don't really want to have a configuration file that you're distributing manually to hundreds or thousands of running proxies and then try to update that configuration file when you change something. So that's what the control plane does. What we offer in AppMesh is a highly available managed control plane. Each proxy that is running is connected to the control plane, and the control plane is responsible for keeping the proxy configuration up to date. So when you go into the AppMesh APIs and you create AppMesh resources, which would be things like a mesh and a virtual service, which you can read about in the documentation what those things mean. You can find examples online that show how to use those constructs. You go into the console or you go into the API, you create your AppMesh resources, and then all of it gets translated into proxy configuration by the control plane, and it distributes that configuration out to all the running proxies for you. So that architecture helps us achieve all of those goals that I just outlined on the previous page. So why the proxy approach? Because you might be wondering, well, wait a second, you're saying you're using this proxy, so now I have to run another piece of code. So why do I have to run another piece of code? What are the benefits of doing that? Well, the benefits are that now I can run that proxy, I can install it and upgrade it independently of my application code. Because it's not like tied in, I'm not building it into the code, I'm not forcing the developers to use a particular library or SDK. The configuration of the proxy is independent of the configuration and business logic of your applications. The proxies have their own business logic and their own configuration. Your applications have their special business logic and configuration, and those two are completely separate from one another. It also minimizes inconsistencies. Even if I am running services written in a bunch of different languages, running on 3 different compute platforms, I can have the same proxy running everywhere, down to the same specific version, and I can use the same configuration everywhere. So I get a nice, consistent configuration of my mesh, independent of the language and platforms that the different service teams are using. So that's why we go with the sidecar proxy approach. Really, the only other option besides a proxy would be an SDK. And with an SDK, I've kind of outlined some of the challenges there already, but it's got to be available in all the languages that the services are written in. We've had customers tell us, yeah, we have an SDK right now that we wrote that does a lot of this, but now we've got a team saying they want to write in Go, and our SDK doesn't work in Go. So we can either spend a bunch of money developing it in Go, or we can tell that service team, no, you can't use Go. So with the sidecar proxy, all those issues go away. If you're using containers, if you're using ECS or Fargate or EKS or Kubernetes, the proxy approach is really easy to implement because you just run that proxy as a container and you run it as a sidecar container. What does that mean, a sidecar container? Well, if you're not familiar with container orchestrators, ECS and Fargate and EKS, they have a similar concept in mind, which is either a task or a pod where you have a group of related containers that you specify in a configuration file, and those containers kind of run together as a unit. And so what you can do with this proxy model, the sidecar proxy, is you can just put in that specification that lists all the containers you want to run in each task or pod, you can just put the container for the proxy into that definition. And now you're running the proxy along with all the other containers that you're already running in your application. And then that proxy handles all of the traffic. So what happens is that if you have other containers that are running in your task or your pod, and they make a HTTP request that's going out the door, that request gets intercepted by the proxy sitting right next to it, running on the same instance. And then the proxy is the thing that implements the, all of the mesh logic. So this pattern is especially attractive with containers. But remember, you don't have to use containers to use AppMesh or to use a sidecar proxy. AppMesh uses the Envoy proxy. If you haven't heard of Envoy, HTTP access log. So every request that comes into or goes out of that sidecar container gets logged. And that log is available as a container log if you're running in a container environment, which means then that it's very easy to ingest that into CloudWatch logs. So now you can have a single place where all of your mesh logs are coming in. Metrics, we have a couple different ways that you can get metrics. So one is CloudWatch metrics, but you can also easily push metrics out in StatsD format, which means they can go into Datadog and some other metrics aggregators. Or you can use a Prometheus-compatible metrics system to actually pull metrics out of all of the running envoys. And the metrics include things like error rates, success rates, bytes sent and received, current open connections, those kinds of things. Tracing, I said before that I would talk about tracing. If you're not familiar with tracing, the idea there is that if I have a multi-tiered architecture, like kind of what's shown on this slide here, where I may have multiple services and like a chain of requests that happen anytime something comes in the front door, it can get complicated in that type of architecture if something goes wrong to diagnose, well, okay, I see an error on the request that came in from the load balancer. What caused that error? Like, was it 3 levels down in my request, or why did that happen? So what tracing does is you inject special headers into the HTTP requests that get propagated through so that you can actually follow and say, well, this request triggered this one, which triggered this one, which triggered this one. And this one here took an extra 10 seconds, so that's why the whole thing took longer than I thought. Or this one caused the error, so that's why I had an error upstream from that. So that's the value of tracing. In some ways, it's a special form of logging. Now, to really do tracing, you do have to instrument your application, because no mesh can magically figure out the business logic inside your application. I can't figure out for you that because a request came in here, it generated a request there. I don't know that that's necessarily going to happen or not. So you do have to put in for whatever tracing system you're going to use, you got to integrate in an SDK in your applications. What we're doing in AppMesh is we're propagating those traces through the Envoy proxies so that you can actually follow not only the traces in your application, but the traces in the mesh also. I'll show you real examples to help you understand what exactly that means. The other piece, the other area of benefit besides observability is what we call traffic management. Means things like, based on an HTTP path, I might want to actually send a request to a different place. The client doesn't know that that's happening. It just thinks that it made a request to a particular URL. But the mesh can route based on the path of that request and actually send it to like different versions of the service, or maybe even different microservices, so that I can have a virtual service that looks like it's a single domain name with a bunch of paths below it, but then actually I've implemented it as a bunch of microservices on the back end, and the mesh is routing those requests to the different microservices, and the clients don't have to know that. That's kind of like microservice to monolith. Like, I have a microservices and I'm presenting it as if it's a monolith. You can easily do that kind of thing with a mesh. So you may already be aware of this, but we launched AppMesh into general availability a few weeks ago at the Santa Clara Summit. Really excited about that. So it comes with these observability and traffic control features. It's compatible across all AWS managed container services, as well as self-managed Kubernetes, and even services running on EC2. That's kind of that key point that I was talking about, that AppMesh is application-level networking. It works across multiple compute primitives. You can even have a single mesh spanning multiple compute primitives at the same time. So how does AppMesh actually work? If you want to get started with AppMesh, what do you need to do? Remember, we talked about the two pieces, the control plane and the data plane, or the proxy. So on the control plane side, you use the AppMesh API or the CLI or SDK, or you can go into the console to create meshes, virtual nodes, virtual routes and routers, virtual services. Those are AppMesh resources that define the connectivity of your mesh. And then you take your service, let's say you're running an ECS service, and you the traffic shaping, the observability benefits, but you can migrate like one at a time if you want to. So I'm actually going to show you a demo now, very simple demo, but if you have your phone handy, feel free to bring up that URL there, app.colortellerdemo.com. I'm going to explain what the architecture is of this application. It is the simplest possible microservice application. There are two services. One of them is called the gateway. It's not an API gateway. Don't get thrown off by the name. It just happens to be called gateway. It's a service that's running in ECS. It's a container. And that gateway container is hooked up to a load balancer, to an application load balancer. And then there's actually like a web application, which is app.colortellerdemo.com, that is using that load balancer. So what happens when you bring up that page, I'll switch to it temporarily, is you see this. The color is red. So what's happening there? Well, there's a web application, some JavaScript, and it's making a request to the load balancer. The load balancer is forwarding the request into the gateway. And the gateway, remember, that's just happens to be the name of it. It's just an ECS service. It's not like an actual AWS gateway. Gets that request, and it turns around, and it in turn makes another request to a service called ColorTeller, which is an internal-only service. The ColorTeller service is not externally accessible. It's running in a private network. And the ColorTeller returns an answer, red. And then the gateway turns around and returns that answer to the web page, and the web page renders the result. Like I said, it's like the simplest possible application. And I can click the button, and you can't tell, but it's actually making requests every time I click the button and getting the same answer every time. So that's the application right now. I actually do have it running in the mesh. So what's actually running is the ColorTeller integrated into the mesh. So what's actually happening is not only is there a gateway container, but there's an Envoy sitting right next to that gateway container. And actually, the gateway container is running as an ECS service, so there's actually 3 of them running in parallel. And the load balancer is sending requests round robin to all 3. And then there's 3 envoys sitting there. The envoy is hooked up to the control plane, and it is emitting logs and traces also, coming out of the envoy, not coming out of my application. My application has no idea that logs and traces are turned on. It's just a very simple little node application that gets a request and makes a request. And then the ColorTeller also has an envoy. So what actually happens when a request comes in from the load balancer is it goes into the gateway. It actually goes into the gateway envoy first. The diagram here is slightly wrong. The request from the load balancer actually goes into the envoy container first, which forwards it to the gateway container. The gateway container says, oh, I've got a request. It came in from somewhere. I'll turn around and make a request to the ColorTeller service. that request actually gets intercepted by the Envoy. The Envoy says, I'm going to interpret what I'm supposed to do with this. You're making a request to the color teller service. I'm going to forward that to the color teller red service, actually. There is no actual color teller service. There's only color teller red, but the gateway doesn't know that. The Envoy and the mesh know that. They know that any request that comes into the color teller service is actually supposed to go to the color teller red service, and the Envoy changes the request and sends it to the color teller red service, which then goes in to the Envoy sitting at the color teller service, which then forwards it to the actual container. So I got like some extra hops in there, but 2 of those extra hops are happening between containers on the same machine, so they're super low latency. They're almost invisible. So like I said, I have this running in the mesh. That's the application that you're actually using, and I hope you're all mashing that button a bunch of times, because we need to generate some data here. I'm going to show you what the traces look like. So this is the X-ray console. What does this mean? So does this have a pointer on it? Doesn't have a pointer, okay. So the thing that says clients, that's you guys, okay? You're making requests. They come into that first circle, the green circle, where it says color teller / gateway, and then you'll notice below that it says AWS App Mesh Proxy. That is the Envoy container sitting in the gateway. There's actually 3, but I'll zoom out a little more here. What you can't quite see, let me see if I reload this, if I zoom out a little bit, there we go. What you can see is that a nice little thing I did here is that actually the color teller red is running on an EC2 instance. So the red service is not even running as a container. It's just a process. I literally logged into a shell, SSH'd into the instance, and typed node colorteller.js, and that's how I ran the red color teller. It's not even a container. Mesh doesn't know, doesn't care. I'm running an Envoy on that instance, so it's doing the same thing that it does everywhere. I also have logging turned on. Now we'll see how much you're really hitting that button. So these are the access logs for the red process that's running on EC2. So I'll just do 30 seconds here. So these are live access logs. Looks like somebody's hitting it a lot. Now what's cool about the logs is that my node application does no logging whatsoever. So imagine I'm the service team for the color teller red service. The boss said, you got to do logging. I said, screw it, I'm not doing logging. Too bad, you're doing logging. The mesh is doing logging for you. We turned it on. You didn't have to do anything. It's logging anyway. And I can get the same format logs regardless of what application language I'm using. Python, Java, doesn't matter. The logs are all going to be in the same format. Likewise, I had those traces where I actually see the envoys in the traces. OK, so now the red team is running on EC2, and they've decided they're going to containerize. They're going to run on Kubernetes, and they're going to change the color. So they want to try out a new version of the service. But being a little risk-averse, the company says, well, we don't want you to go to Kubernetes and change it the color all at the same time without testing it out a little bit first. So let's just start routing a little traffic to it. So we've already got a new color running, and it's already running on Kubernetes. We've got color teller green running. It's already up and running, but no traffic is being routed to it. So I'm going to go in, and I'm going to edit my route. I'm going to be a little aggressive, and I'm going to send 50-50 traffic. You know, really, if you're doing a canary deployment, you should do like 90-10. But for the purposes of a demo, so I don't have to click the button 10 times to get green to show up, I'm going to make it 50-50. OK? Will you all hit the button, please, and tell me what you get? People getting green? You saw how fast that showed up, right? It takes about 5 seconds or so, maybe 10, for the configuration to change. The beauty of this is that the gateway service has no idea that red and green exist. All it knows is I'm making requests to a service called ColorTeller. I change the mesh, and now I start routing 50/50. I'm going to hit the button to make sure we're generating enough data for X-ray. I can go into X-ray, and once it updates, we should see green. OK. So now I see that I have red and green. And you'll notice kind of where the arrows come out of. So the gateway container, the circle in the upper left, the traffic looks the same as it did before. Comes in from the Envoy, goes back out to the Envoy. Where what changed is the Envoy container itself, that circle on the lower left, which is the proxy for the gateway service. It knows about red and green, and it knows when it gets a request for the ColorTeller service, it's supposed to split the traffic 50/50 between red and green. And so that's where we see the arrows come out. So what I like about this X-ray view is that it's kind of showing you what's really happening. You have your conceptual view in the mesh of, I just have service making requests to ColorTeller, and this is showing you what's actually happening. And you can even drill down and look at individual, and this is just a function of X-ray. This isn't unique to AppMesh, but you can drill down and look at individual traces and see the timing and see like how much time did the mesh add to my requests. So for example, here I can see that it was about 1 millisecond of latency due to the proxy sitting in front of the ColorTeller red service. Millisecond. I think I can accept an extra millisecond to get these benefits. So really nice that I'm able to make that change to my configuration and have that change show up live. And green is running on Kubernetes. So I now have a mesh with 3 different compute services, ECS, EC2, and Kubernetes, EKS. And it's all the same mesh. Because I'm not tied into a particular compute platform, I can run my mesh across multiple compute platforms. I can even use the mesh to help me migrate from EC2 to containers. And my other services don't have to know that that's happening. So, a lot of people, when they think about service meshes, they have the idea that somehow you need to be running a microservice architecture first, and that you need to be running in containers or running in Kubernetes first before you can use a mesh. We actually think the reverse, that a mesh can help you transition to a microservice architecture, and it can help you containerize. That step 1 in your microservice and container journey is get running with a mesh first. Get AppMesh up and running with your existing services. Then start refactoring, redesigning, getting things running in containers. It'd be a lot easier to do that if you have everything running in the mesh first. Okay, so super simple demo illustrates the concept. As you can imagine, these same concepts would extend out to hundreds, many, many services running on thousands of containers. Same idea. I do want to mention the partners that we launched with, especially in the areas of observability. There's some really nice solutions here to bring in all these different metrics, logs, and traces into a single pane of glass. Some partners working in the area of security, helping you to secure your mesh and your containers. Some of them are working on solutions that actually do really nice controlled deployment, where they're doing that weighted routing that I showed you, but they're automating that with the deployment, so that as a deployment happens, they're shifting the traffic for you, monitoring the metrics, and automatically rolling back the deployment if the AppMesh metrics get outside your defined thresholds. Some really nice partner solutions. Roadmap. So we're really working at AWS on being much more transparent publicly about what's coming. So in that vein, we're telling you here what's available today, but also what's coming soon and what are the bigger, longer-term projects that we're working on. So near term, you're going to see a lot more features in the area of traffic shaping. That's what most of those things on that list are. Longer term, things like mutual TLS and mesh peering. Mesh peering means, can I run two meshes and have them talk to each other instead of having to put everything in one mesh, for example. Now, this is subject to change. We're going to, as more customers use this and tell us about it, I'm sure we'll be adding to this list and changing some of the priorities, but really want to be transparent with you and tell you what's coming to the best of our knowledge. To get started, you can go to the product landing page. It's got some documentation there, getting started guides. We actually have a public roadmap on GitHub also, so that roadmap that I just showed you is available on GitHub in much more detail. If there's something that you want AppMesh to do, go to the roadmap on GitHub and create an issue. And if we hear about it, we think it's a good idea, we hear from other customers, there's a good chance that'll get into the product. We're also doing something really new for AWS that we're calling the beta channel. And the concept there is that some of those features that are coming soon will actually be available in beta form before they go into production. You'll be able to literally try out a feature while it's still in development before it goes into production, which to my knowledge is something that we've never done before at AWS. We've done previews like we did with AppMesh where the whole service was kind of in beta. We've never done a service that's already released and now we're adding features to it and giving early access to those features. That's not some kind of whitelist thing that's open to the public. Anybody that has an AWS account will be able to try out the beta channel. So with that, thank you. Thank you very much for staying late here. We're really excited about AppMesh and the things that it's going to be able to do for our customers. So if you haven't tried it out yet, please do. Let us know through GitHub what you need, what you want to see. And please do also complete the session survey. We really take those seriously, so it would be great if you take the time to fill that out. Thank you.